Today, me and my group will present our case study related to surface, subsurface water drainage and pipework.
This is our group members. We have Arfan Hakimi, Muhammad Shahid, Nur Akila and Siti Sarah.
Assalamualaikum, good day everyone. Today we are exploring a critical work of modern building drainage system. Our presentation title is Surface, Subsurface Water Drainage and Pipeworks. It provides a comparative analysis of how we manage water at the surface and subsurface level, and the complex pipeworks system that tie all it together. To illustrate this concept in the real world, we will be examining two projects of vastly different scale. First is the Mezzo, the Light City in Penang, and the Shanghai Tower in China. While the physics of water remain the same, we will see how the scale of building completely dictates the engineering response. To understand why we need advanced drainage, first we have to look at the urban water challenge. The rapid urbanization has replaced our natural absorbent landscape with impermeable footprint like concrete and asphalt. This drastically alters how water flows, creating several threats such as urban flooding, water ponding and soil erosion. Perhaps most dangerously for a boulder, it creates hydrostatic pressure against foundation, which can lead to instability or leaks. In modern era, the engineering imperative has shifted. Building can no longer simply shed water, they actively capture, control and convey it to ensure the structure's survival. A complete building drainage system is composed of three primary components. First is surface water drainage. This is our first line of defense. It captures rainwater from roof, pavement and external area using gutters and downpipe to prevent structural erosion. Second is subsurface water drainage. This happens below ground and its job is to control groundwater and alleviate hydrostatic pressure against foundation using specialized tools like perforated pipe and drainage blanket. Third is pipework system. Think of this as the building security system. It is the uneven internal network constructed from materials like PVC, HDPE or cast iron that convey capture water from various collection points to beneficial discharge or retention system. To see this system in action, we are comparing two distinct engineering realities. On one side, we have Mezzo, the Light City in Penang, a 24-story residential development that prioritizes practical efficiency and gravity at disposal. It represents the standard of high-density residential living on reclaimed land. On the other side of the spectrum is the Shanghai Tower, a 127-story super-tall skyscraper at 632 meters. The engineering challenge are exponentially greater. Here, water management isn't just a disposal, it's a complex sustainability featuring siphonic drainage and massive resource recovery system that treat water as a vital asset and rather than a hazard to be removed.
For our first case study, we selected Mezzo or the Light City, which is a 34-story residential development located at Jelutong Reclamation Land, Penang. The project consists of 456 apartment units built on top of a 6-story podium. One of the main reasons we choose this project is because of its location. Since it is constructed on reclaimed coastal land, the engineering conditions are quite different from the normal development. As shown in the image, the building is located very close to the waterfront. This means the site experiences a relatively high groundwater level, which increases the risk of groundwater fluctuations and different settlement. Because of this site condition, the drainage and pipework system become much more than just a system to remove water. They are also essential for protecting the building foundations, maintaining soil stability, and preventing moisture from accumulating around the structure. Therefore, an efficient drainage system is a critical element in ensuring a long-term safety and durability of this development. Based on our case study, the project adopts a gravity-feed drainage system. Instead of depending heavily on pump, the drainage network uses the natural slope of the pipes to carry stormwater and wastewater toward the discharge point. This makes the system more energy efficient and easier to maintain. For the construction methods, the project uses the conventional open cut trench method. The construction process starts with trench excavation, followed by pipe bending preparation, installation and jointing of the pipes before the trench is backfilled and compacted. This method is widely open because it is practical, economical and suitable for underground drainage installation. Looking at the outcome, this drainage network is designed for rapid disposal rather than water storage. In a high-density residential development like Mezzo, the priority is to remove stormwater and wastewater as quickly and safely as possible. Overall, the gravity feed system provides a reliable, low-maintenance and cost-effective solutions that support the operational needs of the large residential development while reducing long-term maintenance requirements.
For our second case study, we focus on Shanghai Tower located in Shanghai, China. It is a 632-meter super tall skyscraper with 127 floors and it functions as a mixed-use building including office, retail and hotel spaces. The key engineering constraint is its extreme height. Because of this, the building must deal with strong wind loads which are reduced through its 120-degree asymmetrical spiral design. Shanghai Tower also follows strict sustainability targets including LEED Gold certification. The main challenge is managing large volumes of water across a very tall superstructure without overloading the municipal drainage system. Therefore, the tower treats water not only as a hazard but also a reusable resource. For this slide, it shows how Shanghai Tower applies a sustainable water management system. First, it uses siphonic drainage where rooftop rainwater is quickly pulled into drain pipes using negative pressure instead of depending only on gravity. Second, the tower also practices harvesting the facade. Its unique spiraling parapet helps capture rainwater from the roof and facade surfaces. This is important because the building has a very large external surface area. Third, the captured water goes through an internal system and water treatment plant. After treatment, it can be reused for non-potable purposes such as toilet flushing and irrigation. Overall, the system reduces the stormwater load on Shanghai's municipal drainage network. It shows that water can be treated as an asset, not just as a waste. This slide compares the underground drainage system between Mezzo and Shanghai Tower. For Mezzo, the system is more standard. It uses underground perimeter drainage to intercept moisture and prevent water pooling around retaining structure. This is important because Mezzo is built on reclaimed land where groundwater control is needed to protect the foundation. For Shanghai Tower, the underground system is more complex. The building has a 5-story basement and a foundation depth of 31.4 meters. Because of deep foundation and soft soil condition, the tower needs strong groundwater control. The system uses dewatering pump, some pits, drainage layers, and pump-assisted discharge to reduce hydrostatic pressure and prevent water accumulation around the basement. It explains the main material used in the drainage and pipework system. First, reinforced concrete is used for underground drainage because it has high compressive strength. It can withstand heavy soil pressure, traffic loads, and underground structural loads. Second, HDPE and UPVC are lightweight and corrosion resistant. In Mezzo, they are used for sewerage and domestic water services, while Shanghai Tower, PVC or HDPE can be used for vertical risers and drainage shaft because they help reduce structural weight. Lastly, cast iron is more suitable for super tall buildings like Shanghai Tower, especially in selected drainage systems that need stronger pipework. Overall, the material selection depends on the building scale, function, pressure level, and long-term durability needs.
Hello, Assalamualaikum and good morning everyone. My name is Arfan Kimi and I'm going to be presenting starting from this slide until the end. So, for this slide is compared to drainage system that used in Mezzo at Lalai City and Shanghai Tower. So for the first one, Mezzo focused on a simple gravity drainage system that sends water directly through the municipal drains. It also has a lower construction cost and requires less maintenance. In contrast, Shanghai Tower uses a more advanced and sustainable system. For example, it collects rainwater through a siphonic roof drainage system and reuse it with a closed-loop recycling system. Although the initial cost is higher, it provides a better long-term environmental benefits. After that, this slide shows some common drainage problems and their solutions. So, this first problem is the ground movement which can damage the underground pipes. So, we can solve this by using a flexible pipe joint. And the second problem is the heavy rains, which may cause flooding, and this also can be reduced by using the detention tanks and a good roof drainage system. And for the last one, is the pipe blockage and leakage can be prevented by checking and testing the system before it is used. If you're looking ahead, drainage systems are becoming smarter and more sustainable. First is smart monitoring, where centers detect the leaks or blockage early before they become a serious problems. Second is the SUDS or Sustainable Urban Drainage System. This uses a permeable basement, green roof and biosphere to reduce the flooding and improve the water management. And finally, the advanced resource recycling allows the greywater and stormwater to be treated and reused for non-potable purpose, helping to conserve the clean water. In conclusion, drainage systems have evolved from simply removing water to becoming an important part of sustainable building design. So, traditional systems focus mainly on drainage, while modern systems also support water conservation, environmental protection, and long-term building performance. By combining efficient engineering with sustainable solutions, drainage systems can create a safer, greener, and more resilient buildings. That's all from me. Thank you.